In this tutorial video, I'm going to go over using MRIcron to identify and work with anatomical regions of interest that can be used for MRI and fMRI-based analyses. So you're going to be working with materials in the MRIcron Workshop Materials folder. See the link in the description if you have not downloaded it already. First, we're going to go inside of this folder, and I'm going to be using the MRIcron Windows version, which I have in this materials folder. See the link in the description to download the MRIcron version that you need for your computer, say if it's a Mac. So I'm going to go inside the MRIcron Windows folder, and I'm just going to left-click on MRIcron to open it. The first thing I want to do is simply generate a sphere in a region that I'm interested in. And so just as an example, I'm going to go to the left hippocampus. To generate these spheres, we're going to use MRIcron's 3D bubble tool. So if I extend this window out, you see this 3D toggle up here in the upper right. So I'm going to left click on it right here. And so your screen should look similar to mine here. In order to generate a sphere, we need to change these settings, the difference from origin and the difference from the edge. We're going to set them to the maximum, 255. So it actually generates a homogeneous sphere. And we're going to change the radius to 3. Okay, so now we have a 3 millimeter radius sphere in the left anterior hippocampus. So let me briefly go over these different settings. So the difference from origin means the difference from the intensity value at whatever coordinate that your crosshair is located. So in this case, it's a difference of 255 from 79. That's the intensity value of this voxel. This is difference from the edge, which is the edge of the sphere that we have here. And so setting both of these difference parameters to the maximum is all inclusive. So all voxels are included in the drawn bubble. You can also set the zero intensity to constrain the edge. So this just doesn't include any voxels with 0 values. If you want to learn more detail about using the 3D bubble tool, you can see my lesion drawing video, which uses this tool to draw lesions in damaged brains. And so you can save this region of interest by going to Draw, Save VOI. And VOI means volume of interest. This is a format specific to MRIcron, and I'm just going to save it into the MRIcron Workshop Materials folder. And I'm going to change it to the nifty file format because I prefer to work in that format, as it is a standard neuroimaging format used by many different neuroimaging software packages. And I'm going to change the name to Sphere 1. So now we have our first sphere, and if you want to generate a bunch, you can go to whatever coordinate, just click around to go to specific coordinates that you want to go to, or you can go to View M and I coordinates to navigate to a specific X, Y, Z coordinate. And if you hadn't seen some of my earlier videos, the X coordinate is up here, Y, and then Z coordinates. So that's what these coordinates match on here. So I'm going to close this file, and let's say you want to generate a mask of the ventricles. That's another thing you can do. So I can select, in this case, the left lateral ventricle, and I want to generate a volume just of the ventricles. So I can again select the 3D bubble tool. In this case, I'm going to increase the radius, something that includes the ventricles. And I want to change the difference from origin now so it's not the maximum, so it won't include intensity values of the brain itself. And let me just set it down to something reasonable like 10. Okay? And so you see that it's only including these very low intensity values that are near to 0. And we can increase this difference from origin. So now we see something that's a little bit more reasonable, and we can increase this radius until it's including all the ventricles. And now we can click around to see how it looks. It looks pretty good. It's not including this portion right here, so we can continue to increase the radius until it does. And then we click apply, and now we have a nice ventricle mask that you can use for, say, doing a PCA analysis on the time series to identify noise components for statistical analysis. For example, again, we can go to Draw, Save VOI, and we'll change it to the Nifty format, and now I'm going to label this CSF. So we can go to Draw, Close VOI. Okay, so let's say we want to draw more spheres. We can do that. And setting these values to the max and 3 millimeter spheres. And I'm going to draw one right here, click apply, and let's say I want to draw a sphere here, and we'll click apply, draw it over here, the left putamen, and we'll click apply. Okay, so now we have 3 different spheres, and I'm just holding and left clicking to view them. And so we can save this, again, as a Nifty file format. I'm going to save it as spheres. So let's say you want to combine the spheres. A quick way to do that is go to Draw, Statistics, Create Overlap Images, and we're going to change the format to the Nifty format again, also called the neuroimaging format in MRIcron. I'm just going to select sphere 1 and Control and left click to select both of these. Click Open, and it's going to create a sum file of these 2 images. I'll call it Combine. Save. And so now you can see the file automatically overlays, and it's combined these 2 files together. So overlay close and overlay add, and select spheres combine to view these different images. Okay. Now this sphere was not there before, and so now it's been combined together. Okay. So you can do this with as many images as you want. If you have a bunch of different individual sphere files or something like that, this is an easy way to do it. If the spheres or regions overlap, then you will get an actual sum. So if I added sphere 1 to this, then the value in this sphere would be 2. Okay, so keep that in mind. Okay, so let's say you want to edit the regions that you've drawn. So let's edit the spheres that we've already drawn. Let's say cut out a piece of a given sphere because it intersects with an adjacent one. So we can go to File, Open, and we're going to select the Spheres Combine file. And again, we'll select the Auto Contrast toggle so we can see them again. And now, in order to view the underlying brain, it'd be good to open another MRIcron window. So I'm just right-clicking on the icon down here, opening MRIcron, and so you have another window, and you can go to View Yoke in both of them to make sure that they're yoked. And so when you click on one, you'll navigate to the same coordinate in the other file. And so we can scroll down, and now we're in the left hippocampus again. So I want to edit this sphere right here, on the left hippocampus. So I'm going to zoom in. I'm going to zoom in by 4 on this particular region of interest. And let's say right next to it we want to have a sphere, but we don't want it the intersection of the 2 spheres. Go to 3D bubble tool, right? And I'm going to click apply. Right, so now we've drawn a region right next to it, and if I click on this hat right here, we can see it disappearing temporarily. So this is the amount of overlap that we want to remove. To do that, go to Draw, Mask Image with VOI, and delete regions with VOI. And this will delete any overlap with the sphere that we just drew. So now if I go to Draw, Close VOI, let's say I don't want to save it. right? It's chopped off a piece right here. And let's do that again. I've just made a sphere again. Clicked apply. Want to draw mask image with VOI. Delete regions. And if I go to draw close VOI, say I don't want to save it, then it's bitten out another three-dimensional chunk from this particular volume. So this is basically a way to do kind of a mask subtraction. So let's go back to CH2 better brain, and we'll have it fit the window. So the next thing I want to do is show you how to isolate a region from a standard anatomical atlas. And so let's open the AAL atlas by going to File, Open Templates, and AAL. I'm going to go to a region that I'm interested in this case, the left fusiform gyrus. So when we're inside the region that we're interested in, we can click on the 3D bubble tool up here in the upper right, and we can set the difference from origin to 1, difference from edge to 1. We can increase the radius to larger than the region we're interested in. You can select the 0 intensity constraints edge and select that, and you can click apply. And so now we have a region of interest for the left fusiform gyrus. I will note that this is not perfect and that some of the voxels on the edge aren't included when using this particular method. So I do have resources in the workshop materials in the ROI tools that you can use MATLAB to get more precise regions of interest. But I'm not going to go over that for this tutorial. The purpose of this tutorial is for these relatively quick identification of regions. Another thing you can do is edit the regions that you've drawn by smoothing them, so you can expand them or contract them. To do this, go to Draw, Smooth VOI, and you can smooth it by, if you want to expand it out just a little bit, be a little bit more inclusive, go to 3 millimeters, and you would decrease the threshold setting to, say, 2, and if you click OK, you'll notice that it expanded out just a little bit. Okay, so now it actually includes all those edge voxels that weren't in the original region. And so you can Control Z if you want to go back to what you had before. Note that the Control Z only goes back 1, so if you make 2 sequential edits, they won't be saved. You can contract your volume by going to Draw, Smooth VOI. Let's say we set this to 3 millimeters. If we increase the threshold to 8 and click OK, and it's going to smooth, but it's going to contract it down to a smaller volume. So this is a relatively quick and useful way to slightly expand or contract your region that you've drawn. Control Z. So another way to do this, beyond using the smooth parameter, is to go down to Draw, Advanced, Dialite Drawing, and now it's expanded out whatever region that you've drawn. When you have your region drawn, you can save it by going to Draw, Save VOI, and change the format to Nifty. And I'm going to save it within the Workshop Materials Examples folder as left fusiform. Okay, so when you have your region, what you can do is you can apply it as, say, a mask on a brain volume. To do this, let's open the templates. Let's go to File, Open Templates, and let's open the CH2 Better Brain. And let's go to Draw, Open VOI, and I'm going to, again, change the format to neuroimaging so we can see the Nifty files. And I'm going to select the left fusiform. And so now we can see that this region is overlaid on our brain. Let's say we only want the region of the brain associated with the fusiform gyrus to be in this file. So we can go to Draw, Mask Image with VOI, and we can preserve regions within the VOI. If we select that, then the rest of the brain goes away, And I'm going to click on this little wizard hat up here. We can see that the actual brain tissue within the fusiform is still present. So we can draw closed VOI. And so now if we file save as nifty, we can save the CH2 better brain's left fusiform gyrus. Let's open up the CH2 better brain again. And likewise, if we want to remove a portion in a region, we can open our fusiform gyrus file again, and we can go to draw mask image with VOI and delete regions within the VOI. And so now, if we draw closed VOI, we notice that the fusiform is missing from our underlying brain. So I'll also add that in the materials I've included in the MRIcron workshop folder are these research atlases. So I have both the AAL3 atlas and the Harvard-Oxford atlas. And so within the AAL3, we have this is the latest version of the automatic anatomical labeling atlas, and also different options for the Harvard-Oxford atlas, in terms of resolution and whether it's cortical or subcortical or a combination of the two. So if I select the cortical and subcortical Harvard-Oxford atlas that I've included, you'll notice that the names aren't labeled. So that's why I've included this Atlas Regions Excel spreadsheet that will tell you which region is associated with which number. So for region 132, for the cortical and subcortical combined atlas, scroll down and see that it's the cuneocortex as defined by this standard atlas. All right, so that's how you can use these to identify specific regions that you might want to draw and use for your own purposes. Okay, so let's say we want to edit a region that we've drawn in a specific way, such as splitting in half, say into the anterior and posterior portions of the region. So let me show you how to do that with the left fusiform gyrus region that I drew. So go to File, Open. Let's navigate. Let's open the left fusiform region. Okay. And the first thing we want to do is actually calculate what the midpoint would be, what the middle slice would be, what the middle coronal slice specifically. So in the sagittal view, I'm kind of going all the way to the anterior portion. And notice in the coronal view, it's almost disappeared. So that's at positive 11. Okay, so we have positive 11 is the very anterior portion. And let's scroll all the way back. And I'm looking here in the coronal view as I'm doing it. And to see when it disappears is the very back of it. So that's at negative 87. So it goes from negative 87 all the way to positive 11 in M and I coordinates. So the total distance is the sum of the absolute values of these, which is 98. So let's calculate the midpoint. So 98 divided by 2 equals 49. So it's 49 millimeters anterior from the negative 87 portion. So let's add 49 to negative 87. And so we can take 87 minus 49. What we get is 38, which is essentially negative 38 here. So we can go anteriorly negative 38 to get the midpoint slice. Now, some of you might not be as knowledgeable about how to navigate in the brain using these coordinates without prior knowledge. To help you, you can right-click on the MRIcron window and open another MRIcron window and have the brain open at the same time. So go to File, Open Templates, and CH2 Better. Okay, so now we can have a brain open that is yoked. Right? Remember, make sure the view yoke is selected in both of them. Again, let's go to the negative 38 slice and the Y. So again, using the Y slice and the coronal view. Now, what we want to do is take this slice out of the region. To do that, we can click on this fill tool, all right? So if I just left click on it and then select the negative 38 slice, you can see that it just fills in the entire slice in this region. And then we can go to Draw, Mask Image with VOI, and we're going to delete this slice. Okay. Draw, Close VOI. Don't save it. And now you see that there is this, Control Z. If you accidentally, fill in, when these fill tools or any of these tools are selected, you have to deselect them. So now I can navigate in this region file again and see that this slice is taken out. So if I want the region of just, say, the posterior portion, I can select the posterior portion of this region, click the 3D bubble tool, and make sure 0 intensity constrains the edge. And then I can make sure that the radius is as large as it needs to be to fill the entire region. Click Apply, and then I would save the VOI as a nifty format, and I would call that left fusiform posterior. Click Save, and then draw Close VOI, and then I would do the same thing for the anterior portion. Again, I'm making sure the radius is as large as it needs to be to fill the entire region. Click Apply, and then draw Save VOI as left fusiform anterior. So we've gone over using MRIcron to draw anatomical regions of interest. Hopefully you found this tutorial useful. If you have suggestions for things you might want to learn to do and see if MRIcron can be used to help you do it, please post a question or comment for this video.